We're going to continue working on the GTX 1070 FE, the one we did the video on yesterday. I'm anxious to get this card working. I posted the video yesterday and we received a lot of comments, 625 comments as of today, and a lot of suggestions. Some of the suggestions make sense and a lot of them not as good. Let's read some of the comments. The comment that is currently trending on this video is from Wayne Sang, 92 likes and a lot of replies. And Wayne suggested that we look at R987 0 ohm resistor on right side of the board. I replied yesterday when I went home and I said that I checked all resistors in the area and nothing was open. He said that the resistor is not next to the area that we worked on from here or the back, but rather it's next to the 12 volt inductor. I checked this entire area. I did not find R987 and I checked the entire board from this side because he mentioned front of the board. I did not find any R987. I flipped the board and I found it. It's right on the back. So this is the 12 volt inductor and the resistor is right on the back, right here. Let's go over it and see what's going on. Right there, R987. Right there. And we're gonna measure to see if this resistor is open or if it's measuring 0 ohms. Meter in continuity mode. And let's see, are we gonna get a beep? And no beep. No beep. The resistor is blown, just like Wayne mentioned. How amazing is that? I could have never figured that out. Wayne just taught us something new. I mean, I'm working on this side of the board, right here, and I'm working on this side of the board. We were missing input, 12 volts, and we were missing VCC. He said that there's a possibility that R987 may be blown. R987 is all the way on this side of the board, right there, on the back. I'm working here, and the faulty resistor is here. I mean, how could you possibly figure this out without a board diagram? It's a good practice to go over all 0 ohm resistors to see if there's anything blown. I did go over a lot of the resistors on this area and on that area, but it was late and I did not get the chance to measure all the 0 ohm resistors. But honestly, I would have never thought that a resistor here may be causing a problem with input on this side of the board. That's why having a board diagram is very important, because it can make life a lot easier. And that's why there's something called the right to repair that's going on right now. If we are able to get our hands on schematics and board diagrams for any specific device, then chances are a lot higher to fix any specific device. Right now we have over 240 graphics cards in the shop here that we need to fix. Overwhelming number of video cards that we need to fix, and we posted a note on our website, on our mail-in form, that we are no longer accepting graphics cards for now until we can finish what we have, because we are behind on a lot of those graphics cards. And especially that every video card is different. Every time I open up a video card, it has a different board layout, and we have to figure out how that board works. If we had schematics and board diagrams, then the job would be a lot easier. On this board, we have the 12 volt inductor right here. We have 5 volts right here. We have 1.8 right here. We have FAX right here. If you look at another card, we may have 5 volts here instead of here. We may have 1.8 volts here instead of here. We may have PICs up here instead of here. Memory may be here and here instead of here. So every card is different. I have to figure out how that card works, and it takes time. It takes time and effort to figure out how that card works. Sometimes I spend an hour or 2 or 3 hours working on one card. Usually I do not spend that much time working on one single device, but the only way to learn how to fix that card is to spend time working on that card. And since we have an overwhelming number of cards in the shop here, I have to learn how those cards work. So having schematics and board diagrams for any specific device is very important. And I hope in the future, if right to repair does pass, that we get at least schematics and board diagrams, and possibly components that we're not able to find that are specific to the maker of the device. I mean, right now, I would say being able to fix a video card is a 50-50 chance. And we tell that to every customer. When a customer calls in to inquire about a video card, or when a customer mails in a card, or when a customer comes into the shop and asks that we fix the card, we tell the customer up front that there's a 50% chance. Maybe we work on the card, but we're not able to figure out why that card is not working. Like this card here. I was not able to figure out why we are missing an input, the 12-volt input and VCC. We do not have schematics and a board diagram for this board. Luckily, Wayne posted a comment and pointed us to that resistor. And the only way Wayne could have known that is if he spent enough time working on that board and measuring many components on the board, or if Wayne read that information somewhere online. But either way, he pointed us to the right direction. Now I know that every time we have an issue like that, I should be looking at that specific resistor. Schematics alone is not enough. We need board diagram. We have a schematic here for a MacBook motherboard model number A203332, and that's how the schematic looks like. Pages and pages and pages of circuit design. Let's go to our ISL chip right here, and let's say the laptop is not powering on. We know that we have current sense resistors here, right there, R7002, and it's very important that those current sense resistors are measuring properly, otherwise the laptop may not power on. So we want to look at R7022. R7022. How can we possibly find R7022 on this board if the parts are not labeled on that board? We see it in the circuit. We know that there's a possibility that R7022 may be faulty, but how can we find it on the board? There's no way to find it on the board. There's absolutely no possible way to find it on the board. Right now, if we take a look at the board, some components are labeled and others are not, but R7022 may be this one here. It may be this one, it may be this one, it may be this one, it may be this one. It may be this one here. It may be this one here. You flip the board. You cannot possibly find where R7021 or R7022 is on the board without a board diagram. And that's why having a board diagram is extremely important. And personally, I think that a board diagram is much more useful than a schematic. I can work with a board diagram and figure things out. But if I only had a schematic, then there's nothing I can do. I can look at how the circuit was designed, but I cannot tell where those components are on the board. Let's open up the board diagram for A203332 MacBook motherboard. And let's search for R7021. R7021. Enter. It tells you the component is right over here. Look at this. Let's zoom out. The component is on this side of the board, and it tells you where that component is. So I orient the motherboard as I see it on the screen here, and I look in this area. The component is right there, R7021. And then I can measure to see if that component is good or not. I can click on that part, and the board diagram will show me what connects to that capacitor. It tells me that this component connects to it, this component connects to it, pin number 1 of that chip connects to it. So then I can possibly look at this resistor, measure it. I can look at this resistor or capacitor, measure it, and I can look into this chip and possibly replace that chip. Maybe the problem is coming from that chip. Some viewers were wondering, and some were surprised, extremely surprised, that we did not inject voltage or check the board under a thermocam. Why would you inject voltage or check the board under a thermocam if we do not have an obvious short? Right now, if I inject voltage on this capacitor when we do not have a short, nothing is going to happen. The component is not going to draw any amps, and nothing is going to get hot on the board. I have my voltage injection tool set to 1 volt. We have ground connected here, and if we inject volt onto the 12-volt input at the capacitor here, look at this. The voltage injection power supply is showing 0 amps. Nothing is going to get hot on the board. Initially, when we had a short on that capacitor, if I injected voltage on that capacitor, then only that capacitor would have gotten hot and nothing else on the board because the short was coming from that capacitor. I figured out the short without having to inject voltage or use the thermocam. So it makes no sense to use the voltage injection tool or to check the board under a thermocam if we do not have an obvious short. So I just wanted to make that clear. Now, if I replace that resistor and the card works, I'm not going to leave Wayne hanging. I'm going to give him $50 as a gift from me for providing useful information. So let's hope for the best. Let's replace that resistor and see what happens. The 0 ohm resistor is right here. Let's go ahead and desolder it. Let's remove that resistor from the donor. Of course, we're gonna measure it first to make sure the one on the donor is good. Right here. Meter in continuity mode. And let's see, is this resistor good? And yes, the resistor is good. I told you that 5 volts on this donor board is good. Now we're gonna solder that resistor on the customer's board right over here. But why don't we prep the pads first, so we have something to solder that part onto. Right now we do not have enough solder on those pads. And we have new viewers. They ask, what's that paste that you apply? That's Flux, Amtech 559. We are one of the major resellers of Amtech Flux. You can purchase it off our site. And let's solder that resistor. Just like that. And now we're gonna reflow. The job is done, but of course we have to make it look better than factory. And we're gonna clean up. And yesterday we removed the chip. We have to put it back. The chip is still on my bench here, and we have to put back that inductor also. Very nice. And let's solder the chip. I accidentally scratched the chip with my tweezer, but that's not a big deal. Chip is good. And pin number 1 should be on the bottom left. Just like that. And that chip is the step down converter, as I mentioned yesterday. Okay, so pin number 1 is on the bottom left, and pin number 2 is the input, which is 12 volts. Pin 7 and 8 are VCC and enable. Very nice. The chip is soldered on nicely. We do not have to touch up on the pins. No need. And if we measure the chip in continuity mode, the only ground that we should read is pin number 4. That's it. The rest should read 0.5 or 0.6 voltage drop. Meter in diode mode. 0.6, 0.5, 0.3, ground, and we have 0.5, 0.5 voltage drop, 0.467, and finally 0.468. Great. So what do you think? Is that card going to work? And since I'm very optimistic, I'm gonna plug the HDMI cable. And we're gonna power the motherboard on. Hopefully we do not hear the 6 beeps, because 6 beeps means that the card is still not being detected by the system, by the motherboard. So let's turn that card on. And the card is on. I do not hear 6 beeps. It's working. The card is working. Wayne, you won $50. Congratulations. You deserve it. Thank you very much for sharing useful information. Customer is going to be happy. I'm happy for learning something new, and I'm sure all the viewers of the channel are extremely happy with your comment. Don't forget to send me your PayPal email address so I can PayPal you that $50. That's it. We're going to end the video right here. I hope you enjoyed it. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.